Alright, and welcome to the Triangle Proportionality Theorem review. Whoops. Well, now you know it's a review, because you've already learned this. We learned this in our very last lesson. Hey, y'all, check this out. What if I said this? What if I said that triangle ABC is similar to triangle A prime, B prime, C prime? Now, I know you're looking at these two triangles, you're probably thinking, oh, they look the same. Remember, in geometry, we can't go by looks like. We have to go with given information. Okay, so I'm telling you these two triangles are similar, and I want you to find x. Now, what do we know? We know we're always looking for corresponding sides. So, for instance, we can say, the triangle that we're going to, the triangle that we're going to has B prime, C prime, and that, of course, is corresponding to BC. And notice, we know that all sides have corresponding ratios, so we could even set up a fraction here of saying that our A prime C prime is then corresponding to AC. So I just basically set up two proportions for y'all, and let's fill in all the things that we know. So we know that B prime C prime is 27 over, we know that BC is 13, and of course this is congruent to A prime C prime, which is 8 over AC. Well, wait a second, we don't know what AC is, so we can put X. Now this comes back from our very last lesson. What method should we use to get the X by itself? There's two ways that I can tell you all this. One, we can do cross multiply 13 times 8, and we can set that equal to, we cross multiply here, 27 times x, or aka 27x. Or, you probably heard of this before, we can call it the butterfly method, and I like to call it the happy butterfly method. Boom. Whatever you want. Basically, we're going to multiply across diagonally. Now from here, let me go ahead and grab a handy dandy calculator. We'll do 13 times 8, which is 104, is equal to 27x. Here we'll divide both sides by 27, divide by 27, and 104 divided by 27 will give us, our missing side length is 3.85. Alright, let's go ahead and do another example of our triangle proportionality theorem. Okay, for our second one, I'll be doing 18, which says given the two triangles are similar, and this is actually 18 from your Google form. Now, here's what I'd say. This is an SAT level question. So if you actually want to see, are you SAT ready, I would actually encourage you to pause this, go try it out, and then come back and see if you're able to do it. And if you're not, then you can actually watch this example and get a little bit of help. Now this says given the two triangles below are similar, we want to find the length of AC. Notice AC is this whole length. Okay, so if I want to find this whole length, I need to find this part Y, and then let's call this other part right here, let's call this X, and then we're going to try and do X plus Y. We'll add them together. Now the first thing I want y'all to notice, it is given that this is a right triangle. How do I know that? Well, if this is a right triangle, and we know this is a right triangle, okay. Now from here we can go ahead and use the Pythagorean Theorem. So, I can call this side A, I can call this side B, and we know that for the Pythagorean Theorem, your hypotenuse, or the side across from the right angle, is always C. So let's go ahead and use our Pythagorean Theorem. A squared plus B squared equals C squared. Let's say we know A is 12 squared, we know B is 5 squared is equal to C squared. And from here we're just going to do some simple math. 12 squared is 144 plus 5 squared is 25 equals C squared. And 144 plus 25 is 169 is equal to C squared. Now remember, when using the Pythagorean Theorem, in order to get rid of the square, we always take the square root. Oh, I don't know what that is. We always take the square root of both sides, and a square root square cancel, and we know that C equals the square root of 169, which is 13. Okay, so instead of C right here, we can go ahead and put 13. Now, why is that important? Well, that's going to allow us to find out what x is. So here's what I want you to do. Pause this video, finish taking notes, and then I'll show y'all how to find x after I clean up this right side. Okay, now we want to find x of this triangle, and let's see what things we know. Here, we know that we have this side AE, so I can write AE. And let's see, what side corresponds to EB? Well, we know that DE will correspond to that, so I'm going to pick DE as well. And we know that if these two triangles are similar, we can get a corresponding ratio between this side, which is going to be what corresponds with AE, will be EC. I know that EC corresponds with AE because it is also the hypotenuse. And I know that EB corresponds with ED, so I can go ahead and put EB. Now, once I have this set up, I can just fill in all my information. I know my big hypotenuse is 13. I know that DE has a length of 5. And this is equal or congruent to EC, the length that we're trying to find, which is x, over EB, which we know is 1. Now remember, we're going to cross multiply. Whenever we have a proportion like this, we will cross multiply. We have 13 times 1, which is 13. And we have 5 times x, which is 5x. And now all we have to do to find x is simply divide both sides by 5. So we're going to say x is equal to, and let me go ahead and do 13 divided by 5. I bet it's 2.6, but let's find out. Yep, it'll be 2.6. Now we know that this side right here is also 2.6. And our original question was, find the length of AC, the whole thing. Well, all we have to do is add those two together. And 13 plus 2.6 will give us 15.6. The correct answer was B. All right, good luck, and I'll see y'all in our next lesson.